See my screen. The purpose of this evening is not to go through the pilot syllabus MET exam. There is a little bit of theory in it, but the goal is to try and help you make your own decisions about where and when you can fly, and to point you to some of the tools that you can use to do that. I'm not a meteorologist. There are a number of members of the club who are, I think we've got a meteorologist, we've certainly got some sailors, we've got some pilots, we've got some windsurfers, and we've got some farmers. And they're all help you make your own decisions about where and when to fly. Then I think it'll be worthwhile. Today, coincidentally, is not only St Andrew's Day, it's the last day of what they call meteorological autumn. That's driven by the calendar rather than by the sun. And so as from tomorrow, we're, at least as far as the weather forecasters are concerned, officially in winter. I think first thing I'll point to is this, on the right-hand side of this first slide. If this worked well, it would be the only tool you'd need, but it doesn't work very well. And it's also based in the Scottish borders, so you'd have to go a long way to find out what it has to say. I've done a brief outline of what I want to try and cover. What causes the weather? Anybody want to venture a suggestion what the main cause of the weather is?
The sun.
Exactly, yeah. The sun is the main cause of the weather. The sun is what determines temperature, it determines pressure, and that determines wind. And the Coriolis effect has a little bit of influence on that because it means that the wind doesn't flow directly from high to low pressure. But everything really evolves from the sun. We're going to look at air masses, a number of other topics, including forecasting models. But let's begin with looking at air masses. There are 6 air masses that affect the UK. There are 1 or 2 others that basically belong in the southern hemisphere. They don't affect us. That's Antarctic and equatorial air masses. But you can see that these air masses either come to the UK across the continent, across the land, or across the sea. And they come from all 4 corners of the compass, north, east, west, and south. The most common of these is polar maritime. And that brings, as you can see here, wet, cold air and cold, showery weather. That's pretty typical weather for the UK. Beneath that, you'll see returning polar maritime. That's basically polar maritime that instead of coming there, has come down and spent more time over the sea before it comes across. So it's not quite so cold, but it still brings cloud and rain showers. The nicest ones, as far as good weather are concerned, are these, the ones that come either off the sea or off the land from the south. What we'll see in a minute is some synoptic pressure charts, and those show front. Front is the boundary between 2 generally mix. You have a lump of cold air and you have a lump of warm air, and one will approach the other, and that will give the result of usually changes in wind and rain. The weather in the UK comes largely from the west or the southwest, and that's influenced particularly by the jet stream. The jet stream, like other weather, is caused by atmospheric heating and the Coriolis effect, but it happens very high up, around 30,000 feet, 5 to 7 miles. That's the height at which aircraft fly and the height of Mount Everest. And it flows across this way from west to east at a great rate, somewhere between 50 and 250 miles an hour. And what we get is we get a boundary between cold air to the north and warmer air to the south. Now, this particular chart was taken excuse me, on the 15th of November. That's when I started putting this presentation together. What you sometimes get is the jet stream actually moving south of the UK. And what it will do then is it will block the weather above it. There was a period in the summer where we had some bad weather because the jet stream was basically stopping that cold weather from moving away from above the UK. You should all at least be broadly aware of synoptic charts. These pressure charts are issued by the Met Office. They're issued for 5 days ahead, and they do give us a good indication of over that 5-day period. Synoptic just means a summary of the current position. What we can see here is for the 15th, 16th, and 17th, as at the 15th of November. First thing to notice is the angle at which these charts are drawn. If you can see, there's a red line here. That is north. So it's not a question of the bottom of the page straight up to the top of the page. It is at an angle. And what we see on the right here, this was a Met Office diagram, but there were storms leaving North America, coming across with the jet stream. Oh, don't need to move that. Coming across that way and drawing in cold weather and adding more energy to the jet stream, making the wind strength greater. If we look at the synoptic chart here, we see these little blue triangles. Those represent a cold front passing over the UK on the Tuesday. I'm not going to go into the detail of the difference between cold fronts, warm fronts, stationary fronts, and occluded fronts, but generally a front means that there is likely to be rain and there'll be a series of changes in the wind strength and so on. If we watch the development of these charts over a period of time, we see that the wind, which on the Tuesday is shown to be southerly, running pretty much parallel to this north-south line, moves round to become more westerly as time goes by. And you'll also see the closeness of these isobars, these circular curved lines. Those are lines of equal pressure. When they're closer together, that means that the wind is going to be stronger. It's worth looking at synoptic charts to get an overall big picture effect of what the week's weather is likely to be. If we move on from that, the question that you all want an answer to is it flyable? Is it lifty? What's the wind strength and direction? And one that sometimes is overlooked, is it actually raining? When I was putting this together, however, I came up with a much longer list. Anyone like to suggest some other factors that we might want to be looking at in making decisions about whether it's flyable on a particular day? To give you a clue, I think I came up with 17 different factors. I'm not suggesting you'll need to look at all of those each time, but there are things that it's worth being aware of. Anybody?
Is it changeable? Is there any changeability over the day?
Change of what?
Wind direction, temperature,
Yeah,
everything.
So let's see what we got. We got wind direction. We got temperature.
Any fronts colliding?
Yeah, fronts. Any more suggestions?
Gust speed.
Yeah, gusts.
Wind gradient.
Yeah, although you might look at that. Probably tend not to look at it that often.
rain in nearby areas, so not on the site, but off in local areas near the site?
Yeah, precipitation. It can be rain, hail, snow.
Cloud level,
What suggestions? What was it like yesterday?
foggy.
Yeah, so visibility. What do we look for in the summer, perhaps?
Cloud type.
Big puffy clouds.
Let's puffy clouds. Cumulus can mark thermals, but there may be days when we have what's called the blue sky day, where cumulus do not form. It doesn't mean there aren't thermals. You can feel them, but you can't see them. Let's push on and have a look and see what we've got here. So no precipitation. We had that. Visibility. One or two of you might have seen my comments on the Red Ribbon Telegram, where the Met Office was forecasting fog this morning. Is the wind on the hill, wind speed, gusts? Are there inversions? What's the pressure? You can get the pressure from the synoptic chart. Inversions you can get from RASP. This is not a talk on RASP. John's done one. It is videoed, and you can find links to that, I think, on the club website. Cloud base. How high are thermals going to go? Is it a thermic day? And how intense are those thermals? Is it a day that's going to be really quite spicy, or are they going to be manageable, particularly by lower airtime pilots? We touched on cumulus, the sea breeze. The sea breeze, as you know, is when the wind comes off the sea against the Met wind and can be quite dangerous. It's only likely to be found during the summer as the land heats up and draws in higher pressure air from above the sea. But you can see that on RASP, and you can also sometimes see it on weather forecasts when the wind direction changes later in the day. If you're flying at the coast, what can be important is the sea temperature. If the sea temperature is warmer or cooler than the air temperature. Similarly, whether the tide is in or out, if you're flying somewhere like New Haven, more in the case of people who are pilot rated and going beyond the point. And whether there's a flood risk. I wasn't aware until I looked at this a couple of days ago that the government now has a website. I'm not sure exactly what you have to put in, but I found it pretty easily on Google. And it will tell you where there are flood risk warnings. For us, the main concern is whether the landing field at High and Over is likely to be flooded by the Cookmere River. So there are lots of things that we can look at in deciding whether it's a good day for flying. But the most important ones are, is it dry? What's the wind strength, direction and variability? And is it lifty? So that's the 3 points on this slide here. I'm not going to spend a lot of time on the site guide and the windrows. Everybody should have seen and read the site guide, but you can see that there are some wind directions, north-northwest, south-southwest, where we have a choice of sites to fly. Beachy Head, being a coastal site, tends not to be good in summer when the air temperature is warmer than the sea temperature, because what that means is cold air comes, it sinks. So instead of going up, you will go down. You're probably all aware that we don't have a westerly facing site. Most of the sites are rated for Club Pilot. A few of them are rated beyond that. And there are 2 coastal sites at Beachy Head and New Haven Cliffs. They're basically soaring sites. There can be thermals there, but they're of a rather different nature to all the other sites that are ridge sites and hill sites on the downs. Before we push on, I'm going to pause and just see if there are any questions at this stage. Anybody? Happy so far? Okay, let's look at what happens to the wind on the hill. Again, if there's anything here you don't understand, stop me and we'll go through it again more slowly. First point, as I'm sure you're aware, is that wind speed increases with height. Second point, weather forecasts that we read on apps and elsewhere are based on the wind at 10 metres. So if you're at Devil's Dyke, you're at 200 and something metres, but the forecast, unless you have it for somewhere of a similar altitude, similar height, is based at 10 metres above ground level. As the wind hits the hill, there will be rotor both at the bottom and at the top. But also at the top, you'll be aware of Venturi effect. So if you're up here, the wind that you feel is going to be greater than if you're towards the front of the hill. What that means sometimes is, when it's stronger, you're better off launching down, lower down the hill, where it's not quite as strong as if you were at the top. Also, it means you haven't got to run so far, and it should be an easier launch. It's not shown on the chart, but the topography of the land, in other words, whether there are spurs and other hills and ridges, that can affect the wind direction. At some sites, that happens more than others, but do bear in mind that the wind that you feel may vary depending on where you are and what geographical features are around you. It can cause turbulence, which may not have been there previously, if and when the wind changes. Only other thing I want to mention here, I don't know if anybody else saw it, but there was a comment from Steve Purdy, I think, about the site conditions at Mount Caburn, where he referred to drainage wind. Just as a sea breeze brings a wind down from behind the top of the hill with cold air coming down and sinking, so not allowing you to fly, but more likely throwing you down into the hill or the bottom below. Also called the katabatic wind. Drainage wind is very similar. It's where some cold air is coming off the hill, and because it's cold, it sinks through the warmer air and comes down the hill, even though the prevailing wind may be in the opposite direction. Any questions on that, or shall we move on? Let's move on. Yeah, forecasting models. The weather forecast comes from data and computer models. We don't need to worry about where the data is sourced from, but all weather forecasting models use that data, process it, and come up with predictions for what the weather is going to be in different places and at different times. And those forecasts may be global or they may be local. Some of them will have a high resolution, which means that they will forecast different weather, for example, between Devil's Dyke and Firle. Others have a much lower resolution and basically predict the same weather forecast for everywhere within a much larger area. Now, clearly, for our purposes, high resolution is much more useful than low resolution. There are a couple of factors that affect resolution. One is proximity. Tend to get more resolution for forecasts that are closer to the current time. And the other is cost. I mentioned that at the end, but forecasting costs money and has value. So paid forecasts, which often involve paid data, tend to be more reliable and better than free ones. However, those paid ones tend to be used more in the commercial world than in recreational world, like paragliding. So if you can imagine a Formula One team at a Grand Prix looking at weather data as to when it's going to rain, when they need to change from dry to wet tyres, the value to them is considerable and they'll pay for that, whereas we're less willing to do so. The other things that are important with forecasting models are how often they're refreshed. They tend to be updated every 6 hours, and at what time they're updated. So if you're looking at a forecast at 7 o'clock in the morning, trying to decide where's suitable to fly, a forecast that has been published at 6 o'clock is probably more use to you than one that was published at 1 o'clock in the night. Similarly, the horizons for forecasts can vary. My view is that 3 days, more than 3 days ahead is really not that reliable. And that's why with the Ribbon Club, I do it on a Friday evening because we've got a reasonably good chance of the weather forecast being right then. Sometimes I'll give an indication on a Tuesday, but that's very much based on how things look at the moment and subject to change. Similarly, the steps vary. If you look at something like windy, and we'll come on to particular models and particular apps in a minute, you can get forecasts of the weather every 1 hour or every 3 hours. And clearly, provided the forecasts are reasonably reliable, having data every 1 hour is better for our purposes than every 3 hours. We would rather know that the sea breeze is likely to arrive at 11 o'clock in the morning or 1 o'clock in the afternoon than only have forecasts for 9 a.m., midday and 3 p.m. I've mentioned 4 of the major models here. This one, called the European model, the European Centre for Medium Range Weather Forecasts, is regarded, I think, generally as the most reliable and accurate. And I was looking at where that view came from. I'm no scientist, but there is a graph here. I think what this says is that because the blue line on the graph is higher up than the red line, and the blue one is the European model, the red one is GFS. The blue model, the European model, has been accurate consistently more frequently than the GFS model. Attention to at the Met Office, not least because it's independent and separate from the European model and the American GFS model. And most apps tend to use one or other of the European and GFS models. Meteo Blue, which is a Swiss model, is also used. We'll see in a minute who uses what. Any questions on models? No? Okay. Right, so what we've got here, we have across the top the Met Office, GFS, European model, and Meteo Blue. There are a couple of other models which I've mentioned here, not least because we find them on Windy. That's Icon, which is the German Met Office, and Aromi, which is the French Met Office. So the only place to find the Met Office is the Met Office. The BBC used to use the Met Office, and then for some strange reason, being owned by the government, a bit like the BBC is owned by the government, the BBC decided to go out to tender, and the BBC now pays money to the Swiss, or to Meteo, for the weather forecast, rather than to the British Met Office. Windy has a number of different sources. There are different versions of Windy and of Windfinder, depending on whether or not you're prepared to pay. My view is that the premium versions of these apps are worthwhile. I reckon it costs me £25 or £30 for a round trip of fuel down to Southern Club sites. And so if I make a good decision based on those subscriptions just once in the year, they've paid for themselves. XC weather is quite popular. Meteo Blue, RASP, I'm not going to go into in detail, but its main initial source of data is GFS. And some of you will be familiar with Flybubble and the Flybubble weather app, and that takes data initially from RASP. It is worth knowing when you're looking at a weather forecast what model it's based on. There's no point in saying, 4 weather forecasts say this and 1 say that, when the 4 are all based on the same forecasting model. If they're all based on the same forecasting model, it's no surprise that they're likely to give the same result. Any questions on websites and apps and models?
Yeah, Robin, Brian.
Hi, Brian.
I'm surprised to see that Meteo Blue is actually a separate forecasting model.
I think I believe it's a proprietary Swiss model that goes into their own app.
Yeah,
I'm willing to be corrected if I'm wrong, though.
That's fine. I'm not questioning what you've put. I'm just genuinely interested in that because I have used Meteo Blue, and I've been interested sometimes to see that it was at variance with the other models that we use. So that probably explains it.
Yeah. Just a word about how I use these for calling red ribbon days. When I first started getting involved in red ribbons, the one thing I was a bit wary of was committing to a particular site, a particular day, and possibly even a time when people, possibly a large number of people, would travel a large distance to turn up on the hill, only to find that the weather was nothing like what I'd expected. My approach now, and I'm reasonably confident with it, it's not going to be right all the time, but then the models and the forecasts are not going to be right all the time, is first of all to have a look at the synoptic chart and understand what's happening in terms of the big picture. Then I'll have a look at Windfinder and see what's being forecast for the different sites. All of our sites I've got on there saved as favourites. That will give me an idea as to which is likely to be favourite. The Windfinder app, particularly the super forecast, which is higher resolution and therefore takes greater account of the topography, gives an indication of how gusty it's going to be as well. At that point, I've got an idea as to which is likely to be the most appropriate site. I'll have a look at the Met Office and see how different that is. It gives me another view on the wind. It also gives me a good view on whether it's likely to be rainy or foggy, and whether there are any weather warnings from the Met Office. Those warnings can be for rain, they can be for fog. It's useful to know. Then I'll probably have a look at Windy. It's possible on the Windy app, we'll see that in a minute, to have a look at what the different forecasting models are predicting. Sometimes they will all be showing similar wind strengths and directions. Sometimes they will be all over the place. Clearly, where different models, rather than different apps, different models are all consistent in what they're forecasting, we can have a higher degree of confidence as to whether that is what we can expect to find when we get on the hill. It doesn't mean that's what it will be. We've all been out, I think, on days when the forecasters suggested it would be flyable, and we've got there and nobody's flown. And similarly, days when we've stayed at home and looked at site reports and found other people are flying happily. That's part of being a paraglider pilot. And John always says in his induction talk, unless you're on the hill, you won't fly, whatever the weather. So sometimes it's worth just going down and having a look for yourself. We'll come on to the apps in a minute, but it's also useful to know how to find particular sites on the apps, and down the side, the various websites and apps that we've talked about previously. In some cases, like the Met Office for New Haven or Windy for New Haven, it's simple. The name is the same. However, if we are looking, for example, at RASP, which is based on gliding turn points, we need to know the closest turn points to the site that we're using in order to be able to look at the RASP data and graphs relevant to that particular site. What I've done here is where they're the same, that's denoted in black, but you see there's quite a few red ones. So if we want to look at Devil's Dyke on the Met Office, this is I think one of John's favourites, look for Truly Youth Hostel. If we're looking at XC weather for Devil's Dyke, there might be a better name for it, but what I've got on my phone is the postcode of the pub. So what I wanted to do is to point up that it's not always immediately obvious that if you're going to High and Over and you're looking at the Met Office, you need to look for Littlington when you're searching on the Met Office app. I said I started doing this presentation on the 15th of November, and what I was looking at is what were these various apps forecasting for the following weekend. That was the 19th. Okay, so it was actually the 17th of November when I put this bit together. So what we see moving from left to right, these are all screenshots from my phone. The super forecast, which is paid for. I think you can get some of it on the free version, but my app's a paid app. It's Windfinder Pro. So it's saying that at midday here, we're expecting northwesterly wind between 11 and 18 miles an hour with partial sun and 7 degrees temperature. If we move across to XC weather, it's also northwest, slightly warmer at 8 degrees and slightly less windy, 8 to 9 miles an hour. I referred, and you can see also what I said about putting in the postcode that's showing at the top here. Windy, I mentioned that you can see visually the wind speed and direction forecast by different models. So this is looking at 12 o'clock, that column here. They're all coming in from the northwest, not all at exactly the same wind speed, but they're forecasting between 10 and 19 miles an hour and slightly warmer at 9 degrees centigrade. Met Office, again, northwest, 10 to 16, 7 degrees. RASP, this is based on RASP by turn point. So we can see the turn point DDK is Devil's Dyke for Saturday, the 19th of November. You can see the wind speed and direction northwest, slightly less wind speed, forecasting 6 knots. What this is showing is, for example, strength of thermals and so on. We're not going to cover that now, but the important thing to know is that you can get wind speed and wind direction from the RASP by turn point. Flybubble takes its data from RASP. It's slightly more westerly, I think, west-northwest, partial sun. So this is what the forecast was saying 2 days before the actual event. It turned out that it was actually a nice day. A lot of pilots were out. So the 19th, it was not last weekend, the weekend before time. This Met Office satellite photo perhaps helps understand why some forecasts were saying it was going to be sunny and some were going to be, say, partial sun. You can see these bands of cloud and a big sunny gap in between. That picture was taken at Devil's Dyke around midday on the day in question, so you can see lots of pilots in the air. There was broken cloud. That's what we call 6 to 7 octas. An octa is basically 1/8 of the sky, so somewhere between 6/8 and 7/8 of the sky was covered by cloud, but there are little gaps of blue peeking through in various places. It's a little warmer than forecast at 11 degrees, but every app forecast the wind direction. It was warmer than all of them were forecasting. Some of them forecast the correct wind strength, some of them under forecast the wind strength, and some of them over forecasted the sunshine. There is not a right and a wrong way of going about this exercise. It basically involves finding the tools that you understand and are comfortable with using and that you find to be reliable. To begin with, you don't need to look at all of these different tools. They will only confuse you, particularly if they disagree with one another. Start by focusing on the wind speed and direction. Do make sure that it's not going to be foggy, it's not going to be raining, that the landing field's not flooded. Do ask whether on the coaching channel or the Red Ribbon chat group. But that is really the substance of what I want to cover. But before we finish, I was going to stop the screen share like that and see if there are any questions.
Robin, could I ask a question about the wind direction?
Oh, I can, but I think it's Tom, but I can only see the top of your head.
Oh, sorry. Yeah. So yeah, can I ask about the wind direction that the club sites take? So you said that the club sites don't have a westerly site, but actually, if it's dead west, then sometimes I see people fly from Mount Caburn, sometimes from Devil's Dyke. And is there some flexibility on the? What happens if you try and fly at a site where the wind's slightly off?
I'll say a couple of words and then maybe John will want to come in. If you're flying, if you imagine being at Mount Caburn and the wind is coming from the west, there is only a very small bit of the conical part of the hill that is taking the wind. So there's only a very small bit that's flyable. If it's summer and it's thermic and you can get up and away from the hill, doesn't matter what direction it's coming, but you won't have much ridge on which to soar while you're looking for thermals to get away from the hill. Similarly, at Devil's Dyke, west is very much the borderline of what it will take. If you think about where the wind is coming when it's coming from the west at Devil's Dyke, it's pretty much coming from to the left of the top of Truly. So you've got turbulence coming off the Truly Ridge. You've got basically wind shadow for Devil's Dyke Bowl. And again, it's not really ideal for flying. Do you want to add anything to that, John?
Yeah. The key thing is, as you fly more, you kind of you really have to respect the weather and the conditions. And you're not, as soon as the wind is off the hill, like Robin has said, you're introducing a lot of other factors. You're introducing turbulence, you're introducing uncertainty in your flight. Yeah, if you're already 5 kilometers away from the hill, it doesn't matter. But we're talking about you're on the hill, you want to launch, the wind is not on the hill. So you're immediately into some obscure crosswind launch. You're not going to have as much lift. You're adding a whole stream of factors that is opening you up to danger flying. You're more likely to have an accident. You're more likely to get collapses. You're more likely not to stay up. There's no ridge lift. The wind is blowing across the ridge, or worse, over the back. It's almost impossible. Now, so having said that, as Robin says, on a thermic day, you will see sometimes pilots, even though the wind is in a weird direction, who launch. But they are going for a thermal. My general advice is, until you've got a lot of experience, and I'm talking 200-300 hours, I wouldn't even contemplate trying to launch from a site where the wind is not where it should be. It's just dangerous. That's really what I would say.
Does that answer your question, Tom?
Yeah, thank you. Thank you.
Yeah.
Anyone else?
What a compliant lot.
Does that mean we won't get any more questions on Red Ribbon Telegram about what I think about the flying conditions at a particular site tomorrow? I will put my thoughts for tomorrow up later, but someone was asking about that, but I haven't actually looked.
I think it's worth, given this is a forecasting thing, to have a quick look. Guys, have a quick look and maybe get people's ideas on.
Do you want to do this, John? Do you want to take back the screen sharing and talk people through what
I'll tell you what. Have you got? Can you bring the Met up on yours, or just a forecast for tomorrow? Bring the Met up for Lewis. It's actually quite interesting.
As you can probably see, my my internet is not particularly fast, but
If I can get it on here.
I've got it now. I've got it.
Okay, great, cool.
Yeah, so let's put that up here.
Great. Okay.
Right,
So if you can
see that now.
if you can click on Thursday.
So we're looking. Yeah, we've got Thursday.
Great.
Yeah.
Let's scroll along a little bit. Brilliant. So, and if you do the show full forecast thing in blue in the middle of the screen, show full forecast,
yeah,
white, right, that's the one. That's the one. Cool. Okay. So now we've got wind direction, wind strength, and wind gusts, and tie that in with the sunshine and stuff. Now, bear in mind, this is for Lewis. You have to add a bit on for the elevation of the takeoff. So we predominantly got north, then going northeast. So if you look at the site guide that Robin's had, then the obvious site to be at tomorrow is Bo Peep. And it's worth looking at this, because it can go one or two ways with Bo Peep. You'll either get there and it'll be blown out, or it'll be too light. Bo Peep has a funny kind of topography where, because of where it's positioned, sometimes we will get the extra wind coming in, like from sort of eastbourne direction, and it just accelerates. But I would say tomorrow it'll actually probably be quite good. Shouldn't be too top end. If it comes to a little bit stronger than that, it should be nicely soarable. And we've got some sun.
Yep.
So there's a chance, a little bit of thermic activity. It's a fairly cold. So we've got what 6, 8, 9 degrees. So slightly chilly. Perfect. So the bit of sun in that will actually help the thermals generate, and could be an interesting blind day tomorrow.
Yeah, and we're not got any likelihood of rain, and with relatively low air temperature, the sun will warm the land. I think it's still fairly damp, the ground, which makes it harder for it to heat up and generate thermals, but certainly not impossible.
Anyway, so that's anyone got any questions about tomorrow, other than what time can I get there?
Quick look at Friday. Right,
Yeah, Friday's
somewhat different.
Yeah, so now I see very overcast, quite thick cloud predicted. In fact, I mean, with total cloud cover. So now what you'll probably find is that those wind speeds will probably get accelerated, because that thick cloud usually means a low cloud base, and that tends to add a bit of compression so that that lower air mass comes through faster. It would not surprise me if that was too strong on Friday. I could be wrong. It's probably worth a look, but I would expect quite fairly strong conditions.
But a reasonably high possibility of rain as well.
I think it's predicting that mainly due to low cloud cover. It's going to be, I reckon, quite a low cloud base. So yeah, it'd be interesting to see. And then Saturday, I think it's picking up in strength, if I remember rightly. Yeah. So
what we do see here is that the weather now is at 3 hourly intervals, so we haven't got hourly forecasts.
Yeah, it's too far ahead for that. But yeah, you can see the base wind on each of these, each day it's gone up a bit. So worth checking on the day, but I think Saturday's going to be blown out.
It looks very cold.
Cold, exceptionally windy, really horrible.
And just to complete the weekend.
Sunday, I think it looks similar. I mean, you have to wait and see. It's worth checking on the day. It's possible.
I'll put something up on Friday like I usually do, but this is one of the reasons why we wait till the last minute before making decisions. I think someone was asking a question.
Nick was asking.
Hi.
Yeah.
Can you go back to the Friday one?
Sure.
Yeah.
Yeah. And if you look at the midday.
Yeah.
And it was, where's midday? 8 to 14 gusts.
Yeah.
Okay. And John was suggesting that could rise because of cloud-based pressure, all that kind of thing.
And also the fact that
it's rising anyway.
This is a Lewis ground level forecast, not up on the hill.
Just while you're doing it, let me just do a quick comparison here. I'm just going to bring up Ditchling, because there's a ditch. They do Ditchling Beacon, which gives you a top of the hill forecast. I just want to give a quick idea. This was Friday we're looking at, wasn't it?
Yeah.
Yeah. So on Ditchling, it's showing basically a base wind of 11 to 13 miles an hour, gusting up to 17 to 20.
Right. Okay. So what I was going to say was you would expect that to go up 1 or 2 miles per hour, yeah?
Yeah. I mean, just looking at it, what they're forecasting at Ditchling, which is obviously a better height. On average, it's
based on what you said before. So that would tally in with what Ditchling's saying. So what would you I mean, for us CP and people, what would you say the kind of range would be? Thursday looks quite good to me. Yeah,
Thursday looks good. I think that'll be totally fine. Bo Peep it's painful. It's a real painful one to forecast, because that 8 to 9 might be 7 to 8, or it might be 15 to 20.
Right.
It's probably the one site I probably go to the most and maybe don't fly.
It's quite a difficult question to answer, Nick. On one of the slides, when we're talking about the criteria to look at, I looked at wind speed, and bear in mind that what we're looking at is wind speed on the hill, the top of the hill where you're launching. So you want it to be strong enough to be able to ridge soar a little bit and take off and stay up. Once you get higher than that, the wind will be greater. A little bit also on the time of year and the temperature. But broadly, in the range of sort of 7 to 13, 14 miles an hour is nice and comfortable for launching, I would say.
Yeah.
Okay.
The other thing I
was just asking because you guys are really experienced, and if you were looking at that and you were going, okay, it's between this sort of range, this is going to be possibly okay, but that's going to be blown out and that's going to be too weak.
Yeah, I mean, we don't get it right all the time, that's for sure.
No, but you must make an estimation before you go, okay,
yeah,
I think it's worth going out to look.
Okay, so that's why I look at Ditchling Beacon, because it gives me a top of the hill one. And 12 to 13, I would go. I would think, okay, this is potentially launchable for me. If it was more than that, if it was like 15 plus, I would go, I'm not going to bother, this is going to be really strong. Plus, the other thing you have to factor in is none of these forecasts will give you the wind speed at takeoff, given the compression over the top of the hill.
Because of Venturi and all that, yeah.
Yeah, they're not. You won't get that. None of them will tell you that wind speed. So there is always a factor of if it looks on, and the way you tend to find it looks on is you've looked at a number of forecasts, you've been to the hill, and you now know, you know what, when it says it's 13 miles an hour above people, I'm going to go again because it's blown out. But it's, as Robin says, I always say, if you know, all you can ever guarantee is if you're not there, you won't fly.
I mean, I'm really, I mean, I'm very close to everything. Okay, pretty much.
Right.
It takes me, you know. But if someone's going to drive for 2 hours, then they kind of need to make a bit of a decision as to whether, you know, what kind of chance it's likely to be. So that kind of range is actually quite important, it seems to me.
But it will vary as you get more. It depends on your level of flying, your level of skill, your experience, your wing, all these things. If you're low airtime, new out of school on like an A-type wing, and you see it's going to be 12 to 13 miles an hour, don't bother. It'll be too strong.
Yeah.
I think the other thing, Nick, is it depends how much time you've got to commit to it. If you're close, you can go, and if it's no good, turn around and come back. If you can afford to be there all day, it might be too strong around the middle of the day and the early part of the afternoon, but later in the day, as you approach dusk, it may drop and be perfectly flyable. So one of the questions that you need to ask yourself is, how much time am I prepared to spend sitting on this hill waiting for the weather to change? Another question I get asked quite a lot is, should I have a wind meter? And I do have one, and I use it only for one purpose, and that is to measure the wind on the hill and put it on site reports. I don't rely on it as to whether it's flyable. It does give you an idea of what 13 miles an hour, 7 miles an hour, gusting to 15 miles an hour feels like. But it's actually the feel of that wind that you need to be relying on for deciding whether it's flyable for you. That, and looking at other pilots and how they're managing with their launches, their ground handling and controlling the wing.
Yeah. There's no cut and dry answer. It's experience, it's visiting sites, it's getting to learn what works and what doesn't. We still don't get it right.
Just thought I'd ask your view, being experienced.
Yeah. Yeah.
Okay, thank you.
My view.
Another question I sometimes get asked is, if it's not strong enough to fly, we can ground handle, or if it's too strong to fly, we can ground handle. The problem is, if it's not strong enough to launch, your ground handling will probably involve running across a field practicing forward launches, which will tire you and bore you very quickly. And if it's too strong to launch, your ground handling will probably result in you being dragged across wherever it is that you're ground handling. The wind speeds are pretty similar for both, in my view.
Yeah, sure. Unless you can find obviously somewhere lower down to ground handle.
Yeah, well, the wind speed is less.
Is less, yeah. But it's true. There's you need to be able to ground handle in speeds that you can launch in. Otherwise, you can't. Everyone says you can't ground handle. And what's worse is you actually risk being lifted, actually inadvertently being launched backwards into the air. That's actually the real hazard about ground handling in winds that are too strong. So you're trying to handle a wing in conditions that are too strong to handle, with a strong likelihood you're going to get hoofed. And even if you don't go, you just get hoofed 10 feet and dropped. That's painful. I mean, I've been on hills where we've had to call out an air ambulance because that happened to someone. They got dumped 10 feet back onto the ground. So it's not a minor point, but you ground handle in conditions that you can keep your feet on the ground.
I see we're graced with Johnny Carr on the call, so good evening and welcome to you, Johnny.
El Presidente.
Good evening, everybody.
I know you started him off.
Have we got any other questions?
Can I ask a question?
Yeah.
Hello. Sorry if you've covered this already. I managed to join late. But
who's asking? I'm not quite sure. I can't see.
Oh, hang on.
If you stop sharing for a minute, Robin, it'll.
Yeah, I need to switch that off. There we go.
There you go.
I'm not.
Sorry, go ahead.
Yeah, that's fine.
Having established good wind speed and direction for the hill, how can we find out what the potential cloud base would be, and what if it is thermic, how to use or how to discover what the lapse rate can tell us about how buoyant it might be, and basically conditions once we're aloft, because I'm yet to sort of crack this one.
Okay, that's the province of RASP, Regional Atmospheric Soaring Prediction, which is a separate talk. We can do an extra one on that. It's a very good point. It's an excellent question, and it's one we spend much time in the summer going over to work out the best place to go for cross-country flying, the best routes to take, the predicted cloud base, the predicted thermic height, predicted thermal strength. So yeah, there's a phenomenal amount of discussion that will go on about that once we get back into season. Between now and sort of really the end of February, RASP, I find, to be honest, it's pretty useless at predicting thermic. It just says there aren't any. It's winter. There aren't any thermals. It's not that good.
Is there a sort of I don't know, a calculation that we can make though that can give an impression of whether or not it will be lifty or not, based on the lapse rate?
Well,
have a look at John's presentation on RASP, and you will find through tepigrams and the RASP by turn point an indication of thermal height, thermal velocity, but make sure you can understand what the different, or how to find the different graphs and what they mean. There's loads of data there, far more than we ever need.
Yeah, okay.
Yeah. But fundamentally, they're not simple calculations. They're done for you, presented to you in chart, graph, or some other format. These you're talking about fairly complex atmospheric calculations that go through a lot of computing to generate the data we want. What I say, once you get to that point, we will next year hold talks on cross-country flying, on the tools you need for it, how to read these things. So we'll definitely go into that in more detail. But what Robin's done covers really what you need to know for the next, 2 to 3 months worth of flying. Where your dominant factors are going to be wind speed, wind direction, and wind strength. Sorry, yeah. Wind speed, gusts, wind direction. Really everything that Robin's gone over. If you honed your understanding of that over the next couple of months, use that data, look at it on the hill, you're preparing yourself for the more advanced stuff. So I would definitely review everything Robin's gone over, practice it, apply it, look at it. Then you've got a good skill basis for the next section.
Okay.
Demetrius is going to post a video of this presentation, and I'll also make available the PowerPoint presentation as well. One final additional point on RASP, just as with other weather forecasts, RASP has higher resolution the closer to the time that we look at it. So a RASP forecast for tomorrow will have a certain resolution. A RASP forecast for Sunday will have a different, larger and less accurate resolution. So like the other forecasts we looked at, the later you can leave it before looking at the model, the more reliable and accurate the results are likely to be.
Yeah, okay. Absolutely. Yeah, but as I say, I don't want to sidetrack everyone into RASP at this point, because it basically sort of detracts from what Robin's been going through, which is building up your core skills of weather forecasting, and just getting familiar with that. But absolutely, I'm sure everyone will want it. We want lots of you going. See, next year we will be doing talks on RASP, reading lapse rates and all that sort of stuff.
Mm.
If you have any questions after we've finished, don't hesitate to put them up on Telegram and try and answer them. Are we done?
Robin, thank you very much.
Thank you, John, Johnny.
Thank you.
For those we don't see before Christmas, can I wish you not only a happy St Andrew's Day tonight, but a Merry Christmas.
Thanks a lot, Robin, and yourself. Good night, everyone.
Probably see you next week, Johnny.
Yeah.